And okay, let's start. So, good afternoon, everyone, and a very warm welcome to today's webinar, exploring the capabilities of RISA 3D. So, myself, Ashwin Nagar, and I'm from Acero Consulting Engineers. We are the official channel partners of the Nimishik. Great to see you all here, and today we'll be taking a deep dive into RISA 3D and its capabilities. Uh, yeah. So, here's a quick look of what we will be covering today. We start with a short introduction to RISA 3D and its core capabilities. We'll touch upon its integration with other BIM platforms. Then we will have a detailed software showcase. We'll showcase you modeling, loading, design, and reporting in action. And lastly, we'll have a look at what the RISA portal looks like. So stay with us till the end. We have a lot of content packed in for today's webinar. And before we begin, I'd like to introduce you towards our today's presenter, Mr. Kirti Chandra Doshi. He's a structural engineer at Acero. Kirti holds a MTech degree in structures from Delhi Technological University, and he has hands-on experience in softwares like RISA, Adapt, Bluebeam, Idea Statica, RFEM, and more. So he'll be taking you through the detailed technical walkthrough in just a bit. And before we dive in, I'd like to showcase uh, what we are here at Acero Consulting Engineers. So we are proud to have worked with more than 300 clients. We have delivered more than 30 products and supported projects across 20 plus locations. But what really sets us apart is we just not your average software seller. We make the softwares work for you. So our team is made up of postgraduates from top structural universities and management universities, and we help our clients enhance their productivity, their workflows, and get the most out of their softwares in the most economical way possible. We do that through knowledge posters, we host regular webinars, and also share resources. And we keep ensuring that you extract the most out of your tools. So all the links to our YouTube, our LinkedIn page, you can find in the chat box. Coming to our project and solutions. So here is a quick look at what we offer under our Nimishek portfolio. We of course have our RISA 3D and our RISA suite. So RISA suite includes RISA floor, connection, foundation for your complete steel design. For PT and RC drawings and designs, we have Adapt Builder and Adapt PTRC. That's for post tension and reinforced concrete. We have Adapt Felt as well. That's also a specialized tool for RC. And Allplan for BIM-based design platforms. And lastly, Bluebeam, that's a PDF collaboration tool for AEC professionals. Along with this, we also have other solutions that are outside our Nimishek portfolio for like Autodesk, Idea Statica, that's for steel connection design. We have Karamba 3D, Shuriken, Adobe, and Aries Trinity from Draper. So Aries offers perpetual licensing options and it's a similar software to AutoCAD. So someone who might be looking for a perpetual option in AutoCAD, which is not available right now, you can have a look at Aries Trinity. We can do a demo for that for you as well. And with that quick overview, let's dive into the software uh, itself. So I'll hand over to Kirti, who will take you through the software and its core features. Also, you'll see some polls coming up. So please do I encourage you to take participation in that. That just helps us understand uh, what kind of software you are looking for and what kind of software we can offer you. So over to you, Kirti. Thank you.
Yeah, I'll be start with displaying some poll questions. So yeah, thank you and hi, good afternoon. So we have another set of poll questions right now, and we'll start with the presentation shortly. So let's just start. So for anyone who is new to RISA theory, I will quickly start with a short introduction. So RISA 3D is a 3D analysis and design software, which is used for the modeling and analyzing the buildings or the towers or the industrial types of the structure or even the tanks and almost any structure. And one of the advantage is its multi-material support. Like you can design the steel frame, it may be either hot rolled or the cold form steel, or even the concrete member, timber, or the masonry walls, and even you can design the aluminum member. Also, the software can perform the linear and non-linear as well as the science, the seismic and the wind load analysis. And it follows all the global design code as well, including the Indian standard, AISC, Eurocode, and more. And you can either manually create the load combinations, or you can let the visa to automatically generate them for you, based on the code requirement also. And because of this diverse flexibility and accuracy, so RISA is trusted by the large number of the companies worldwide, and it supports the various project types such as the industrial structure, towers, or the stadium roofs, or it may be the tanks or the complex metal buildings, or even if you are working with the residential or the commercial structure. Also, the image on the right hand side is of one of the project carried out in RISA 3D. It's of the US Olympic and the Paralympic Museum. This is carried out in the RISA 3D and is analyzed. RISA 3D is used to analyze its complex, the spiral geometry and multi-level, the concrete and the steel structure. So here I have highlighted some points like why do engineers prefer RISA. So first is, like the model creation in the RISA is easy, like the interface is clean and also the intuitive, and also it is designed how engineers actually think and work, and the RISA also gives you the tool, that are specific to each of the modeling needs. So the next is the integrated workflow. Like if you are working with the other tools, RISA tools like the RISA floor or the connection or the RISA foundation, like you can easily transfer the data between any of them. Also, the next is the reporting features, like the output from the RISA isn't just a number. Like you will get a detailed numerical as well as the graphical results, and also the diagrams and also the step-by-step design check. So all the other points mentioned below, like are about the trust and the usability of the software. Like it is built by the engineers and taking in concept for the engineers. So the logic behind the software, make actually the sense technically. So RISA has been, also development for more than 30 years, and the technical support is also responsive. And the important is it comes with the cloud-based flexible licensing, so multiple team members can use the software. So here you can see, like you can integrate RISA, with the other tools like the Autodesk Revit, or it may be the Tekla or SDS2 or the Architect, or even through the Excel. So the integration, in the RISA 3D is achieved through the link, like basically, which comes within the RISA 3D. For example, like engineers can work with the architect by transferring, model back and forth from the Autodesk Revit using the RISA Rabbit Link integration, as you can see here. And also by using the RISA Tekla link, anyone can easily transfer the geometry or even the member and the design parameters to the Tekla structure that may be used by the detailers and fabricators. The others are the SDS2 and the RISA architect link is also there. So it is used to link the architectural model created in the Graphisoft ArchiCAD with the structural engineering model in the RISA. In the right hand side, you see RISA 3D connect smoothly with the other RISA tools like RISA Flow, RISA Foundation, and also with the external platform. It means like for example, RISA sections allows you to create the custom shapes and the sections for you to directly use in the RISA 3D. Also, I mean, like the RISA Flow, RISA 3D, and the foundation, yeah, even the connections are integrated, like they operate as one program on the same model. Like, for example, you can optimize the gravity system in the floor and the lateral system in the RISA 3D, or then you can perform or carry out the connection design in the connection RISA connection, and the foundation system is taken part in the RISA foundation, and the complete information of the complete the information flow is seamless between one software to the another. Also, I would like to highlight about the how the link work. So as you can see on the screen, this is the RISA Rabbit link, which is a free type of utility that allows to transfer the data between the Rabbit and the RISA. That means you can build a model in the Rabbit, and you can just push it into the RISA for analysis, and then you can bring the result back. So here is the workflow of RISA to the Revit transfer. Like to enable the smooth integration, you first need to install this link, and once you have installed, you will see the import and the export options under the like the add-ins tab in the Revit interface, and you can just export the analytical model directly from the Revit to the RISA 3D. Like you can see the options of transferring it to the RISA Flow or RISA 3D in which of the software you want to export. Like for example, if you have bought the programs like RISA 3D and the Revit on the same machine, you can just check the launch RISA box and it will open the model in the RISA automatically. But if you do not have the RISA and Revit on the same system, then you can definitely import the exchange file. Basically, this is saved in the file location next to the Revit, and that exchange file can be imported in the RISA 3D later. So as far as the Tekla structure, the workflow is similar using the RISA Tekla link, just like the RISA Revit link. So here is I have added some case studies. So RISA website has lots of the real world examples to show like how the engineering companies are using the RISA software. So the software, like the case study, consists from the large scale stadiums to the complex building geometries also. So you will see, once you go through the risa.com and you will see the options of the case study, you will see how the flexibility of modeling, the connection to the Revit, and the speed of design iterations, like make it solutions, one go solutions for both the design and the optimization. So you can just check out this later at risa.com/case studies. So you will get a lot of case studies. Also, the important point is like how to manage your RISA license. So the RISA customer portal is the online platform where you can manage your software license, or even can download the updates and access the support resources that are available for the RISA 3D. So it's also the RISA portal also provides the link to all of the tutorials, documentation, or even the training materials. Like you can see on the screen, it has a lot of the columns available here. Like the portals, also link directly into the cloud licensing system. So you can log in and use the RISA from anywhere on any of the system. So regarding the licensing time, obviously it's a cloud-based subscription license. Means it provides flexibility across its users. I mean, like the multiple user, can be assigned under the single license. In the below tab, you can see you can add the different types of the users under the one license, but only one active user can use it at a time, and anyone from anywhere can have access to the software. So also you can see how many licenses have been consumed or not. So all of the information is provided under the project, like the product usage part. So this is the interface about the RISA 3D. Like the interface is extremely customizable also. Like you can adjust your toolbars or even the menus and view different types of the layout according to your workflow. And also RISA has the pre-built templates that we'll discuss today, and that helps to start a modeling quickly. Like you can generate common structural systems automatically, like the frame templates is there, like the truss template, tanks or the domes. For example, the receive the circular templates that I will going to demonstrate. The circular templates may be used, for example, like the aircraft hangars, or the grid templates in the RISA 3D is also available there, which may be useful for the industrial or the commercial types of the structure. And the truss templates work, well for the bridge or the roofs, or even the cylindrical templates is there that works well for the chimney type of the structure or the silos, or even the water tank templates for generate the rectangular water tank. So I created a short video for this. So let's watch this. So I have opened the Visa software already, and this is the interface you will see. It will check for the license, and you have the options to create the new license, and even you can import the samples model that are available in the Visa 3D. And below tabs you will see the lots of options for tutorial. And right now I have opened the new project so that you can display your company names and designers also. So I have already given my company name here, and I've already provided my name as a designer. Also, you can set out the project information in the left hand side as well. So this is the interface, and in the top side you can see the different options, like where you want to save your file, where you want to capture the image, or to print options are available there. So under the file also you can see how to open any types of the file. So I have opened one project files already using the file options, and I can give again the different model name to the different types of the files. And even I can so I'm just I've already given the company name I here, and I will just write my designer name here. And all of the informations you can just note down here in the project information. So you will have the options of changing the unit from, if you're working in the imperial or the metric, you will get all the options to change this unit. And in the model settings, you will see whatever the settings you want to apply to the model. For example, it has the settings available. So you can see the different types of the codes so that are available for each of the member. Like for the hot steel, there is the Indian code also available. So for the concrete, different codes are available. So similarly, IS code is also available here. So for the concrete also, you can set out the model and rebar spacing, minimum percentage of the steels and everything. You can set it out. And in the top ribbon, you can see the different options under the home, like the members, how to add members, how to add area loads, and different types of the loads, and the basic load case. So you will see the options of select by property. This is one of the important features in the RISA 3D. Like it will help you to select the particulars member by assigning its features. So I want to select the columns type, beam types of the members. So if I use the select property, it will select me the beam types of the structure here. So this is great to visualize. And if you want to see which like a particular member, you can just select it by this dim lock options, and it will show that particular members only. So this is quite easy. So you can get the options of copy and move tools available here. So I've already used the copy tools to copy this member to a different location. So this is available. And the one you have see is the diaphragm. So you can hide or unhide the diaphragm as well. So This is like if you have any of the member and if you want to add the nodes and if you want to split it, you can just use it under the modify options. And under the view property, you can see the model view in different forms. Like you can see here as a wireframe view, like the full render view is not available here because I have set the render to only the 80%, and if you set it to the 100%, you will see the full render model. But for the wall elements, it even not 100%. So if I change it to the 100% for the plate and the wall panel also, then the full model is available here. So you can set your settings from the model tab as well. Even you can see the wireframe view, color coded, and the 3D render models from the top side. And if you want to see the particular sections and the memory information, you can just click on these icons and it will show you the different types of the sections, shape, availables. So all of the information can be easily available. And if you want to see the particular node information, you can definitely click from this. So all of the options are available. So the drawing tools can be used to generate the, if you're working for the grid, so you can just open these drawing tools and it will be helpful to place your coordinates. And in the spreadsheet form, you will get the different options for section sets where you can provide your like the material property or the design parameters. And you have the options of different types of the shape available, moving load, times, history, and the response spectra also are available under the advanced tab. So I have set out the hot roll still property to the different shapes, like the database are available for different types of the section for either hot roll, cold form, wood, or the element types of the structure. So you can definitely change this. Even you can find all of the information from the left hand side. This data entry table is available, and you can definitely dock this into the main window so that you can get the project like the one in one window. You can get the steel property, you can get the section set, and even you can open a model, so you can use this property also. So in the model also, if you want to see the load, like you can set what types of the load you want to see, then you can, it will show you the area loads or whether it's a point load. You can definitely view the loads that has already applied in the model. Like you can definitely change the basic load case, which load you want to see. So right now here is the wind load on the wall, so I've selected that load and this load has been shown only. So this is the way the interface is like you will get all the information here, and it will be helpful to select which of the parameter you want to select. And even for the loading, you can apply the different types of the load. You can change the magnitude of the load. Even once you click on any of the members and load, then you will get an option to change these parameters, and you will see what are the loads applied in your models. And you can definitely change the units while working on the model itself. So it will change my kips per feet to the kilonewton per meter once you use this change unit property. So all of these features are available. So this is the quick interface about the user interface. Now the next is the modeling templates. So I will start there. So there are lots of the templates available for like the circular, parabolic, 3D grid templates. So I'll start with the circular templates. So you can generate, you can give the angles, and you can even define the section sets to the members you want to create out, and the different types of the sections are available. And I've already selected one sections, and you can even set out the design rules. So for the SSS section, I've used the tube design rule set, and you can even dock this window within this, and you have your circular templates available, and you can easily copy it in the different intervals. So I can use the copy features to copy it to the different locations. So once I've used the copy feature, you can see the Z direction is this side, so you can just give the multiples arc within the Z directions, yeah, by using this template. So the next is the truss template is already available here. You can select the different types of the truss, and you can give the different heights according to this. So I have already given the A to 1.5 and 3.5 feet. So and even you can define the numbers of the panels, how many panels you want in each of the directions. And even you can define the truss dimension to measure from center to center or out. So you can also define the releases also to the waves of the cord. And even you can define all of the members to the top chord, bottom chord also. I've already defined the tube types of the members here. So you can definitely change the angle of this member also. And also you can define the unbraced lengths also within the templates. And I've already copied it in the multiple locations. So using this truss template, so even in a minute you can, generate this type of the structures. So using this truss template, so it will help you to reduce the the multiple repetitive tasks. So for example, I want to delete some of the other elements, for example, to zoom in into it. So I can go on, okay. If I want to see the sections of this, I can go on this property to select the save property, and it will display me the sections for each of the property. And if I select any of others, and it will give me the length. And even if you click on releases, it will show you the I and the J releases. So this template is available, and you can also define the boundary condition to the truss. So I've already applied the pin connections in both the sides. So you can define the boundary condition using these options. And once you click on apply to select it, it will help you to assign the condition, boundary condition. Then you can apply on loading to the truss. For example, I have created a line load of magnitude under the dead load. So y is the vertical direction in RISA 3D by default. So you can definitely change this direction also. So I have applied the uniform, like not a uniform load. I have applied a tapered load of 2 and the 3 magnitude. So next is the grid template. So you can this template can be used, to define the industrial types of the structure having the different uniform, multi-story level. So you can define the different types of the sections, and even the materials you can select, or the sections and the increment injection in both of the directions. So once you set up this, you can definitely draw this type of the grid types of the structure using the templates. And you can see it's in the form of the render view, or the wireframe view, or the 3D view. So the next one is the rectangular templates. You can define the tank height and the dimensions. So you can also apply the water pressure load. So you can also apply the plates. So I've already used the concrete here, and you can add the top or the bottom stiffness or the intermediate stiffness within the tanks. And there is the fluid load options available also, and it will automatically calculate you the hydrostatic load based on the parameters you have provided. So using the tank template, I've already created my water tanks. And to this, we can also go to display the loads also. So the full render view I have opened for the plate. So the tank has already the water pressure load with all the stiffness available using the water tank templates available. So you can easily use any of the templates and start modeling. So other one is the geodesic dome templates is available here. You can just use these templates to create a dome type of the structure, or even the circular types, like the cylindrical types of templates is available that may be used for the cylindrical structure of the chimneys. So you can just use these templates based on their needs. So the next is the file compatibility and exchange within the RISA 3D. So regarding the import, you can open an existing RISA 3D or the DXF file, or even the STAD or the AutoCAD, like the Autodesk Revit file, the Tekla structure file, or the TNX tower, or the SAFE file within the RISA 3D. And in the right hand side, you can see it allows you to export the current RISA file in as a DXF also into the ADAP builder file, which is another product of the Nemetschek for the concrete design. And even you can export it into the SAP or the Revit or the STNF file. And also model, you can export the model data to the Excel also. Like the file type STNF is still detailing the neutral file. That is a file format used by the number of CAD and the still detailing. So this format is, superior to the DXF export, and it contains the member size and the orientation information as well. So these have the ability, to import and export the file types in the ESAF format as well. So which is the structure analysis format file. So I have created short video for this, like to how to use import their DXF and start the model. So in the right hand side in the directory, you can see RISA can be linked with the RISA Foundation in the RISA connection also. So in the import option, you will see the different types of the file options that I have shown in the previous slide. So you can easily import the stat files. If you have the stat file, you can easily import this. You don't need any of the link for this. And in the export also, there is the file types like the DXF, STNF file, which I have recently discussed. So I have my DXF file regarding some tower types of the structure, which is created in the AutoCAD. So what we'll do is we'll just use the RISA import feature to import this DXF into the RISA 3D. You can under the drawing tools also, there is the options of import DXF grid. You can definitely import it from here or it's the file tab. Once you import this, you can select the layers, or you can just select the increment also, like you can see in the top side here. So you can set this while importing. And once you are done, you can just click. So you can just we have just imported that DXF file into the RISA 3D. Then after, you can just click on assigning the members and everything, and you can carry it out, placing the loads and everything in the RISA 3D model. Like the AutoCAD model can be imported directly into the RISA 3D. So this is like a kind of the workflow. So we'll also see like how you can, export. So I will show you, like there is the SAF file, like how you can export the RISA 3D model into any other different types of the software for carrying out the, for example, connection types design. So this is the structure analysis format file, which I have discussed previously, like the RISA have the option to export it into the SAF file. So it contains all the information, member force and geometry. So what we'll do is we'll just change the coordinate to the Z, because in the universal software, the Z coordinate is the vertical, but in the RISA, it's Y by default. So we'll just change this one thing only. And what I will do is I will try to import the RISA model into the Idea Statica for the connection design that pivot kind of the buildings. And using this ESAF file, you can open this file. It is in the form of the Excel. You can just import your whole model from RISA to the, for example, Idea Statica software, and you can definitely carrying out perform your connection design. So I just want to highlight like how the SAF file from RISA 3D can be used uh, to export the model data that can be used in the another software. So the next feature I would like to highlight is the P delta analysis. Like it is essential, to capture the secondary effect, like the second order effect, which may be important for the slender or the tall frames. Actually, when a column, or the frame deflects under the load, that the deflection change in the direction of the load, which causes the additional moment. So this secondary effect, can increase the stress and also reduce the stability, specifically in the high-rise buildings or the industrial frames. So ignoring the P delta can, sometimes underestimate the design force and lead to the, the unsafe result. So well, in the RISA, these second order effects are included in the analysis, which gives a much more realistic representation of how the structure behaves under the load. Also, we'll see how you can apply the additional parameters like the thermal load or the tension or the compression only members in a model using that may be useful for modeling the bracing or the strut. So we'll jump into the P delta analysis in the RISA 3D. So I have a kind of the brace frame model here. I've already created a model, and you can see the different types of the view, like the wireframe render view. So you can see the different types of the section sets available if you click on this view. And I have lots of pin designed here for, and I just want to check whether the P delta can, whether if you run the P delta analysis, this frame is stable or not under the applied load. So we'll check how this P delta can run in this model, and how the software, how the models is stability or not, and we'll type to fix this error. Also, you can see I have some bracing here, and which are applied in the form of which are already applied as a braces using a steel rod, and we have already provided this as a tension only members. Like the tension only member has been provided to the braces, like you have the option to set out the both ways Euler buckling tension or the compression only members. So kind of the frame I have here, and some of the loads, vertical loads under the dead load is I have already applied, and under the live load also I have applied some of the loads. So I have a frame model ready with some of the pins, and some of the loads are already applied. Now we'll check into the load combinations, and we have already generated the load combination. There is the option of LC generator. If you click on this, then the program will automatically generate the load combination as per the code. So I have generated the different types of the loads here. And under the settings, or the input and the output setting, there is the options like whether you want to, for example, if you untick this option, you won't get any of the notification if there is any error in the model. So you can make sure that to set this under this application settings. And there is the options of P delta analysis, and whether you want to solve it for the standard nodal shear and the geometric nonlinear stiffness. So all the settings I have already applied. And once you click on any of the load combinations, so I have shown the options like P delta divergence issue is there. So we'll check how to fix this error. So under the right hand side, there is the option to open the help file. So we'll jump into the RISA help file, like what actually the P delta analysis is. So there is the option of P delta analysis and P small delta analysis. So uh, what we'll do is we'll go to the load combination again, and we'll just untick this P delta. So here you can see the P delta. So I will just remove this, and we'll run the analysis to see whether this error is coming from the P delta or some other things. So I will try to run this analysis again by removing the P delta for this particular combination only. So now the solution included one or more combination without P delta analysis. So after I clicking on OK, now it is giving me the analysis, but some instabilities are there within the model in this particular node. Like you can see, this model is locked right now, so we didn't get any of the moment here. So we will see, like we will try to capture it through the select property tools. Like it will jump me directly into this particular node, and we are getting some instability right now. I have assigned the pin condition, but I will assign some of the spring to this node, like the two spring is there. So I will just try to write some values here, like for example 0.1 kips per inch. So once I set this, and I will just try to rerun this again. So I will just run this particular software. So right now it is trying to solve. Right now we have getting this locked issue has been solved by assigning some springs here. But we will check like, but this is without the P delta, right? So we'll check whether there is some flexibility issue in the modeling or something. So we'll check the deflection limit, but using the deflection feature also, I'm not getting the proper way, like whether it's coming from the flexibility or not. So I set up my deflection limit to the 90 so that I can zoom it the bit more. So from this also, like the columns, uh, we can see the deflection shape. So right now, this also doesn't help me to find the exact issue. So what I will do is I will try to create a nesting load case for the P delta. So for the particular combination 7, we are getting some instability for the P delta divergence issue. So what I will do is I will just write the load combination 7 and we'll run the P delta analysis. But the earlier we have considered it for the full load of 100%, but right now we'll check it with the 90% of the load. So I have applied the factor of 0.9 to see that P delta divergence issue will be solved for the 90% of the load that are not. So even for the 90% of that load combination, it is giving me the error. So I'll just run the iterative process for 80% of the load. Yeah, for the 80% of the load, it is giving me the solutions, but it is giving me the warning log that I have, select the tick option before in the application setting. So the warning you can click directly by placing the cursor on this question mark, and you will get a lot of what's the warning you are getting. So basically, it is given me the tension. You just need to change the tension compression member to the bath phase. So regarding the first error, it is regarding the stiffness adjustment, like the calculations stopped after this tau 1.0. So this is regarding the stiffness adjustment, and you can just change that setting also. Now I can see again the deflected shape. Right now, the issue seems like because of the flexibility. So under even these loads, even this model has only the vertical loads, not even the gravity or the lateral, like not even the lateral load. The columns is not, the model is too much flexible. So what I will do is I will just try to uh, change the size, SSS tube size for this column. So there is a multiple steps to check the P delta conversion. So this is not only the one solution to change the section property. So I have highlighted, increase the section size because I saw that the column is not stiff enough. So right now the issue has been solved for that. So, but what I will see is now I will see the deflected shape and increasing the shape, that the deflected shape looks okay to me. So by this way, you can set out the different types of the carried out this P delta divergence issue. And in the brace, like we'll apply some thermal load that will act as a pre-tensioning. So thermal load is one of the way to apply the pre-tensioning, as you can also see within the RISA helpdesk file to introduce the pre-stressing in the model. So there is the equation how to calculate the thermal force. So what we'll do is we'll check what are the member force we are getting. So under this member force tab, we'll see what are the member force we'll get. And in the material tab also, there is the options of thermal coefficient and all that will be used for these calculations. So section set all of the properties, area, moment of inertia, all these properties are under this material in the sections tab are available. So for this particular post, right now, I just want to keep it back to my original shape. And for that particular combination, like the load combination 7, I just want to run this analysis so that the P delta without this load combination, now it has given me the model because we have already removed the P delta analysis. But what I want to check is the member force so that I can introduce my, the thermal load as well to calculate the thermal load. So you can definitely filter out your load values here. So I can select only the tension only members because I have applied the brace as a tension member. You can just filter out the result here. And you can have also the options, just to sort these values from absolute maximum to the minimum, so that right now I can see the actual values in the keeps. So what I will do is I will just use these equations to, to calculate the thermal force. So what I will do is I will just place the thermal load. So under the load direction type, you can just see the thermal load option and start taking magnitude, and the in magnitude you can just place it, and you can see now the thermal load has been applied, and this will act as a pre-stressing in the cable. So by this way you can apply the thermal load and you can just calculate it. So under the load tab, also you can see if you want to run any of these particular combinations, you can get to see now you will get to see the member force now that might have been increased because I have introduced the higher thermal force. So right now it has been 0.41 something. Right now, after introducing the thermal source, so 0.479 is there. So this is the way to introduce the pre-stressing in the model using the thermal load as well. Also, we'll see like the design, like the member design optimization feature in the RISA 3D, that adjust the member size for the minimum weight to meet the code requirement and also the controlling criteria. So you can also even modify the properties in bulk and apply the filters options like we have seen and adjust the member in offset also and even apply the unrest length and the effective length factor as well. So we'll just look into this quickly as well. So I will just show that, but before that, I will also want to highlight that after you are done with the analysis, both the analytical and the design related results, you can generate and you can show both the color coded as well as the deflection or the contour plots for any of the load combination on your model. So also the additional information is available in the spreadsheet form, which you can filter and print what you need. So basically it includes spreadsheet and output graphics to document your design. And you can also, see the design step check for the limit state design check for all of the governing equations. So I have some properties here within the RISA 3D that can be used to solve this model. Yeah. So this one is the match property. This property is basically, to match one of this member or the sections to the other. For example, I have the white flange here. Like, for example, you can say W12 into 26 and W14 into 61. But if I want to change this to 14 into 61 to 12 into 16, I can just use this match property available in the top side under the modify options. Then you can definitely change the section set. So it is quite easy. So here you can see I have already used this match property to change the section size. So other is the swap ints. For example, you have the I and the j int, like the starting and the end point of any of the members. The I is shown in the red and j is shown in the green. You can select any of the members, and in the modify option there is the swap options, and you can use these options to the swap your I and the j int. It has the multiple features to use this. So once you click on swap ins, you can apply to selected also, then it will select to particular member. But if you click on the swap in and there is an option to keep the tool active, once you active this tool or tick this tool, the program command will active and you will just use it repetitive. For example, like, so I can use it for the multiple ways to swap the ints. Yeah. If I click on these options. So the next is the member offset. For example, if you want to give offset to any of the member, you can definitely use this. So I have one model ready. So right now the beam is in the center of this column, like the node is there in the center, but I just want to offset it in this z directions, x direction. So right now what I will see is my column height is 9.7. So what I will give the offset of 9.7 by 2. I will select any of this member and I will got to see the I and the J in. The I is the red one starting, and I can go on the additional parameters. So I have given this 4.75. Right now it has not shown me the shift because the wireframe view, the rigid offset is off. So I just need to open this. Right now you can see the member has been offsetted and it has been connected using the rigid link. So in the similar way, right now it has moved, but for this side, I also want to use this. So this is an important feature. You can just use the member property, member name here, like the M88. So it will just offset it without giving the actual dimensions. You just want to offset this member particularly based on this. So you will see the rigid links for both of this member. So this is, and if you want to offset it in the vertical direction also, you can definitely do that. So for example, there is the analyze it offset features option. So by using any of these features, you can definitely offset your member. For example, I have given the offset of 10 inch to this particular member, so it has moved it to the vertical directions. So if I select the minus y, so it has moved to the downward directions. Even for the local z axis, so you can see it has a bit moved in this z directions, and if I given minus z, so it will move in the other directions. So using these options, you can definitely provide the offset. And the effective blend factor calculations is important for the stability analysis. So you can see the KYY and the KZZ value in both the axes. So by default, it is set as 1. But we will use the program feature to calculate the effective length factor. Right now, you can see this has no I and the J relays. Both ends are the fixed. And right now it has given calculated me the effective length factor. And right now, similarly for the other, by using this feature, because we have only used the selected members only feature, so effective length factor for this member has been calculated. But if we use the program features to use it for all of the member, then effective length factor for all the members can be calculated. So right now there is the pin in both the models, but we want to make it the fixed. You can definitely change this to 0.65. Yeah. So it has calculated based on the boundary condition. So if I click for all of the members, then for all of the members, the effective length factor has been changed and can be displayed graphically. So this is the program optimization feature. So I have already applied some of the load and will just run this analysis. Right. So it will take some time to run this analysis. And after that, we'll get to see the code check values and the material takeoff. If we click on sort options, then you will get to see the node reactions and everything. So in the right hand side, the result tab is active, and you can see some of the members are filled right now. But you use the sort feature, then we'll see the maximum utilization is 140%. So right now for this particular combination, the material takeoff for this steel is you will get the values. So, but after using the program suggested design shape, you can just rerun the analysis, and program will suggest the shape based for the minimum weight, and the controlling criteria is strength right now. So you can see the material takeoff has been reduced. So you can just use this program suggested design features to help in the member optimization. Right now the code check have also been passed from 140%, it has been reduced to the 90%. So in the result tab also, you will get to see all of the results in the form of the spreadsheet. It can also be seen from the right hand side. For the detailed report, you can just click on any of the report, and you can just click on the report for that particular member. It will give you the report with all the diagrams available and the steps of the limit state design check. So you will get to see all the equations also. Right. So you can select on any of the members. So it will give you the report because the report tab is already active. You can also print the report from the top. There is a print report options. So you can get whatever the input parameters you have provided. You can just tick this to include this in your reports, whatever the design or the input parameter you want to print in the report. So once you give all the property, you can just save this in the form of the PDF. You can just print this report. It will save. So I just want to highlight some points regarding the on this length also. So for this, I have applied the three beams on the column. So the LB and LBYY are the top and the bottom flange, and L compression effective lengths for the top flange and the bottom flange. So on this length, so LBYY basically prevents it from buckling on the Y and the Z axis. So we have given it one case we have not provided any of the commands, and for other we have provided the segment command. For example, the segment command is used if you have any of the intermediate node, then it will just consider that node as an unrest length. So I've just selected these three options and will just check the results. So by assigning the different unbraced length, what I meant to say is it gives me the different code sec values and the pre-compression forces. So even for the column also, we have assigned different unbraced length. So it will give me the different code sec values. So it has been, I just want to highlight is it's mandatory, to highlight the unbraced length properly. So you can also see this from the this report. Like you can see the unbraced length factor here. So the unbraced length, yeah. So unbraced length has been used for the 15, and here is the 7.5. So it has calculated me accordingly. So you can just provide the unbraced length from the design additional parameter design parameters, and you can just check out the values. So this is just a quick process of how you can set up this. So to summarize, like what we have seen far, so we have explored the research interface and the modeling tools. Uh, so that actually helps you to build the structure quickly and accurately. So we also discussed the integration through the RISA links and the BIM utilities. So we also have looked at the features like the pre-delta analysis, member optimization, and the design code. And finally, also have seen how this, helps you to produce the reports and exchange the file and work efficiently across the multiple software. So we'll display some poll questions here, and we'll also take some of your questions.
So thank you, Katie, for the detailed demonstration. It was really insightful, and I hope our attendees also find it insightful. And in the meantime, we get the questions. I have some frequently asked questions from our existing clients and from our previous webinars. So let's hope and clear those questions as well. So first of those questions, many questions that we get is, can RISA 3D be used for cold form steel?
Yes, Ashwin, RISA 3D, can be used for CFS design using the American and the Canadian as well as the Mexican design code. So RISA 3D, also have various CFS database and also the various shapes like the C sections, which may be the single C or the back to back or the toy to toy, or even the jet sections, head sections, or the tube sections are available. So yeah, it can be used for both the CFS member and the wall design. Yeah, this can be used.
Second question we have is, how convenient is it to export light gauge models from RISA 3D in Vertex BD for production of CNC file for actual production from machine?
Um, so there, isn't directly currently a direct method of integrating or exporting between the RISA 3D and the Vertex BD. Uh, but I think you could achieve this by exporting your RISA model into the Revit first by the way of the RISA Revit link that I have shown. And then you can import that Revit model into the Vertex BD, particularly by the way of their IFC export. So I believe that once you have it in an IFC format, you should be able to import it into the Vertex BD for the production of CNC file.
Thanks a lot, Kiki. So, is there any option in RISA software regarding the type of foundation, that is octagonal foundation, square foundation, or type of foundation support, that is soil foundation or pile cap foundation? And does it support the latest ACI codes?
So Ashwin, regarding the foundation design, so basically it is carried out in the RISA foundation. So RISA foundation is the another product from the RISA, but it can be integrated with the RISA 3D. So RISA foundation, yes, supports the rectangular and the the circular pedestal type. So, but regarding a coexist to the octagonal pedestal, one way to define it may be, to define a circular pedestal that can have a outer dimension equal to the overall dimension of the octagonal foundation, but the slabs that supports the pedestal can be of the any size of the geometry. Yes, regarding a cohesive, the software also do the pile design for a slab supported foundation in addition to the soil supported slab. And yes, the foundation, and yes, for the foundation, it supports the latest ACI code as well. Yeah.
Thanks a lot, Preeti. So just a couple of more questions. Another most commonly asked question is there a way to import stat files and Tekla files in RISA 3?
Yes, Ashwin, you can easily and directly import the stat files. I have shown you in the import options also that stat files can be directly imported into the RISA 3D. But for the Tekla, you can import it by using the RISA Tekla link. It's just like the RISA Rabbit link what I have shown in the webinar.
Last question, Kirti. Can we carry out steel connection design in RISA 3D as well?
Again, yes, but RISA 3D, yes, you can carry it out, but RISA 3D can perform the steel connection design only through the integration with the RISA connection, which is again the another product from the RISA, and it also supports the codes such as the ACI, AISC, for I mean, or in the Canadian code. You can carry it out, then you can carry it out, perform different types of the connections in the RISA connections, whether it's the moment connection or the shear connection or the brace connection or splice or even the base plate. What I mean to see is RISA 3D, RISA foundation and connections are, integrated, that they operate as one program on the same building model. Yeah, you can carry it out by this way.
Okay. Thanks a lot, Kirti. So since we do not have any other questions in the Q&A chat box, uh, we'll move forward. So if you like to explore RISA 3D yourself, we encourage you to take the 10 days free trial, which includes all the features, and we try to provide full support, just like a real license purchase support would be like. And you can check that out. You can download it from lisa.com or simply just write to us at Acero, solutions@acero.in, and we'll help you get started, or you can call us both levels. Here's a big look at what kind of clients and the existing customers of RISA. So RISA is trusted by engineering firms worldwide, and from construction to industrial design and everything else. Its adoption continues to grow, and because of its speed and accuracy, and most importantly, the ease of transition from any other software to RISA is it's very remarkable. So what our clients say, here are some of the clients' reviews and feedback that we have gotten over the years. So our clients often tell us that RISA gives them the freedom to model exactly the way they want, and mirroring their Revit geometry, and instantly see how every change affects the performance. So other clients say that they love how RISA combines with the power with simplicity, and strong enough for complex projects, but yet it's intuitive for everyday design. So coming to the support and learning at RISA and Acero Consulting Engineer, support is a priority for us. So you will get a dedicated channel for phone line, emails, and online help, along with a good response and quality of support. And the option for licensing is it will be a cloud-based annual subscription for flexible licensing options. And we also provide comprehensive learning resources like webinars, courses, tutorials, manuals, and knowledge bases. You can also explore the RISA Learning Center uh, training at the at training.risa.com to get certified and stay updated. So coming to our upcoming webinars, we have Before we wrap up, we have two other seminars we'd like to announce. So in the end of October, we'll take a deep dive into Adapt Builder for PT and RC design. And in mid-November, we have a session on 2D for digital collaboration. So you can follow us on LinkedIn and subscribe to our YouTube channel to keep updated. I'll share all the links in the chat for this. And here is our contact details. So if you want to visit our office or write to us or call us, you can check the website and email links there. You can note down this number to call us back. And finally, on the behalf of self-consulting engineers, I want to thank you all for joining us today. If you'd like a demo session, custom code, or discuss integration with your current workplace, please feel free to reach out to us. Thank you, Kirti, and thank you all once again for joining us in today's webinar. I hope it was insightful to all of you. Stay safe, have a good day ahead, and I hope to see you all in the next webinar. Thank you all.
Happy. Thank you, everyone.